Okay, so yesterday we did applications of exponential functions. Y'all are way too loud. I am not going to talk over you. Yesterday we did applications of exponential functions that were biological in nature. We did population growth, we did radioactive decay, things like that. Today we're going to look more at the money side of exponential functions, probably the side that's most useful to you. A few of you may go into a biology field. All of you will deal with money at some point in your life. Hopefully you will deal with it well. That would be our goal in this, that we learn how that works. So this asks if you have $1,000 in a savings account at 3% interest compounded annually. What compounded means is that's when the bank takes your interest and puts it in the account. How many of you have a savings account of some sort? Maybe monthly, do y'all see a little amount go in? How many of you it's not monthly, it's not that often? Like maybe quarterly, 4 times a year? Or yearly it goes in, right? So y'all have seen that happen? That's what compounded means. It's when the bank takes the interest and puts it in your account. So says it's compounded annually, so they're going to put the interest in your account once a year. How much would you have after 1 year? $1,030. Why $1,030? Nope. Not exactly 130. Did you with the E? Yeah. Not quite the same. 45 cents would start to add up, wouldn't it? Good. 1,000 times 0.03, right? It's like not that complicated. No E's. This is just money. You just multiply it by 0.03 and then add it up.
I did something different.
What'd you do?
Okay, I moved, like my mom says, 10%, move the decimal. So it would be 100, and then I would do 100 divided by 10, and then I would times it by 3. You get 3.
Okay, good. Very good. So you did the exact same thing just in your head.
Yeah.
Yes, perfect. Now, I want to challenge you to think a little outside the box. Perfect. I want everyone to hear this. Martin said he just multiplied by 1.03. Why would multiplying by 1.03 get you the same thing? It's 103%. Why do you really want 103%? You want the $1,000 that you already had plus the 3%. So that's an interesting way to think about it. It is a great way to think about it. It will help us in a moment. What about after 2 years? What would you do? Do what?
The new percent per share on
Yes. Would you want your new savings amount to be calculated in your new percentage? Because do I have $1,000 anymore?
No.
No. How much do I have now? I have $1,030. If the bank doesn't give me the interest on that 30, I'll be a little bit upset, right? Yes, ma'am. Oh. You have the answer? Do you have a question or an answer? Oh, okay. Okay, what is it?
1,060 and 96.
1,060 and
96.
And how did we get that? We multiplied this by 1.03 again. Everyone agree with that? Would you agree that you keep multiplying by 1.03? So the amount in the account is the $1,000, the initial amount you had, 1 plus 0.03 or 1.03. And you're going to multiply that over and over and over again. What happens when you multiply by something over and over and over again? How does that look in a formula? an exponent, a t, maybe for years. You multiply by 1.03 one time for 1 year, 2 times for 2 years. If you wanted the amount in the account after 5 years, you'd have it to the 5th power. Any questions about that? This is called the simple interest formula. You take an amount and you multiply it by 1 plus the rate raised to the t power. It's called the simple interest formula. That's if you're compounding once a year. This is a more general formula. This is the one banks use. Write it down. Write everything below it. You will need it. Combined with the PERT formula, yes. A is the amount after t years, or also known as the future value. It's kind of like the A was yesterday, except it's a different, it's money instead of bacteria. P is the principal or present value, so it's the amount you start with. R is the annual interest rate, of course expressed as a decimal. M is the number of compounding periods per year. That's why it's divided by M. Remember the first one was just compounded annually, so we divided by 1, and it didn't really show up in the formula. But if we're compounded quarterly, a lot of banks do quarterly. That means you get an interest payment every 3 months. How many of you have a bank account that seems like it's about every 3 months you get an interest payment? Yeah. That's a very common way for banks to do it. Annually is once a year. Semi-annually is 2 times a year, so M would be 2. Quarterly is 4 times a year, so M would be 4. Monthly, of course, is 12 times a year. And when they do daily, banks use 365 days a year if they do daily. There aren't exactly 365 days in every year, but that's what they use. If they do weekly, does anyone know how many weeks are in a year? 52. So if they do weekly, then they do 52 times a year. Your bank uses a calculation like this to do your interest payments. How many of you have seen this before? You have? Okay. Anyone else? A couple of you? So you're learning something. Do you think it'd be important for you to know how much money you're going to have in your savings account after 10 years?
Yeah.
So you could see how this would be an important addition to your knowledge. Okay, I do want to contrast this with what's called the continuously compounded interest formula. And I want to tell you when you use what. One of the most common mistakes is to use the wrong formula. And you will get incorrect answers that way. The PERT formula is mainly used in biology problems. Every now and again, textbooks will make you do it with money. My accountant husband hates it when they do that because he says no bank ever uses continuously compounded interest for money. It doesn't happen. And he is probably right on that because he knows much more about that than I do. But textbooks will occasionally ask you to use it for money, but the only way they will is when they say continuously compounded. And let's talk about what continuously compounded means. Remember, compounding is when the bank calculates interest, right? And banks are going to stop and do that once a year, twice a year, 4 times a year, something like that. Population. Do rabbits stop once a month and have babies? Is that how that works? No, right? That doesn't happen. We can't go, okay, go now, right? That's not how it works. Population, bacteria, half-lives, those are always compounding. As soon as something happens, it compounds right then. Does everyone know what I mean by that? That's why the PERT formula is used in biology, because it's for continuously compounding interest. Banks don't have that luxury. Somebody has to push a button. I don't know if you know that with most of money things are kind of manual. Someone goes in. My husband works at USA Truck, and he has payroll in his department. And there is a lady that her job is to push the button that makes everybody get paid that week, right? There's a job. No, she has more to her job, but there's a lady that is her main job. Her most important job is to push that button. Well, that's the same thing with a bank. There's a calculation that happens where they have to go in and give you the money. It doesn't just happen, not like biology just happens. So PERT is used for things that just happen. The only way we will use it for money is if some book problem tells us to do continuously compounded interest. Again, that's not a very realistic thing. Every now and again, textbooks will make us do it, and we will comply, but it's not a very realistic thing. Okay, so suppose that $2,000 is invested in an account at 5% per year compounded quarterly. How much money will be in the account after 3.5 years and after 10 years? Well, what am I going to do? So I have $2,000 and I'm going to put it in a savings account that's getting 5%. Very unrealistic right now. Not always unrealistic, but 5% is better than any bank right now. But when I was in high school, you could get 5% interest in a bank account. Anyone who having a savings account, what kind of interest you get?
I feel like points.
Yes. Not very good, right? It does. Right now. Now the market will change and that will change eventually.
30%.
Do what?
30% now? Like, well, make it 30%.
It might someday. I mean, you just never know. They change it based on the market, based on how much. Because what banks do, this is totally off topic, but I'll mention it while y'all are writing this down. Banks give out loans to homes. That's how they make their money, for home loans. And so right now the home loan mortgage rate is, like, you can get a home loan for about 4%. Right? Well, they use your money to fund those loans. So they pay you part of what they make in that loan interest. Well, they're only getting 4% right now for home loans, so they're only going to pay you a portion of that. They used to get 8, 9, 10% on home loans, and so they would give you a better portion. So it just depends on how much they're making from home loans and what the national percentage is on home loan rates at the time. That's how they decide. And that's why interest rates are so low. If you're a home buyer, that's a great thing because you can buy a house at a low interest rate. If you are an investor, it's not a good time. You kind of hope that when you get out of college that the interest rates are still low because you probably don't have a whole lot of money to invest, but you do probably want to buy a house at some point. So it would actually be in your favor if interest rates stay semi-low for a while. Where if you're a retiree, that would be the opposite for you. You would hope if your home's paid off and you're investing, then you would hope for better interest rates. Okay, so this is our formula. Where does the 2,000 go? What is R? What is M? Good. How do you know it's 4? Quarterly. Quarterly is 4 times a year. You put in how many times a year? And then 4 times T. Well, the first T I'm going to put in is 3.5, and then the second T I'm going to put in is 10. If you wanted to put it in your Y equals as a formula, you can. That way you can just go to your table and type 3.5 and then 10, or you can type it in your home screen twice. Either way. Make sure, everyone listen to this, make sure both the 4 and the 3.5 are exponents, not multiplied. So what do we get after 3.5 years? 10,400 and what? So your $2,000, you did no, is that what you got? Is that what everyone got? That seems pretty high. 2,000, 1 plus 0.05 divided by 4 raised to 4 times 3.5. Yeah, 2,379. Here's my typing. So what'd you do, Kyle? Okay, so what percentage rate were you looking at? 50%, which makes more sense that we would grow at that kind of rate. So 2,000, yeah. So if you're getting a 50% return on your money, keep it there. And 91 cents. Okay, so $2,379.91. So doing no work, we gained $379 in that 3.5 years. Okay. Now go replace that 3.5. Do y'all know how to use your on your calculator? Do y'all know you can go up and grab something and pull it back down and go change a number?
Yes.
So I'm gonna go change that amount of years to 10 years, and after 10 years I have $3,287.24. Any questions about that? Small changes in the interest rate will make big changes in your final amount over several years. If you can get a 5.5% instead of a 5%, someone just run that really quick with the 0.05 as 0.055 after 10 years. Just the 0.05 to 0.055. Yeah. So 5.5%, just a tiny change in the percent for 10 years. So you get $200 more just by a 0.5% change. So small changes in percent make big impacts in the amount. What doesn't make as much of an impact as you would think is how often it compounds. A lot of people think if you're compounding daily, you're going to just rake in the money. Not necessarily, because you divide the rate by that, by how often you compound. So that doesn't change your amount. Now, it will give you a little more if you're compounded more, but not as much as a small percentage change. So you don't want to shop for how often they compound. You want to shop for interest rate, is what I'm telling you. If you're looking for a bank account, the interest rate is key. How long would it take for me to get $2,500? So say you're putting it in a savings account to save for something. How long would it take your money to make it up to $2,500? How would I do that? 2,500 equals 2,000, 1 plus 0.05. So this is the same bank account. But now I want to know, what is T? I would suggest that you solve this with a calculator. It's not impossible by hand, but you'd have to use log base 1 plus 0.05 divided by 4, which a lot of you will, that would hurt your brains. I'll show you that, but I would suggest doing a calculator. How would you solve this in the calculator? Intersection. That's, yes. So I'm going to put 2,500 in Y1 or Y2, either way, and 2,000, 1 plus 0.05 divided by 4 raised to the 4x. So if you want to see what my calculator looks like, that's what I've typed in. What does my window need to be set at? Let's talk Y values first of all. What do the Y values need to be set at? At least 2,500, right? So 2,000, you can even set your bottom at 2,000. You start with $2,000. If your bank account doesn't go up, you're in the wrong account, right? So from 2,000, we better be going up from there. So if you wanted to set a minimum at 2,000, you could. And then I'm going to go with 3,000 for my max, just so I can have a little leeway to see the intersection. I don't know how long it's going to take, but how much money did I have after 10 years? $2,379 after 10 years. So it's going to take me longer than that, right? To get to 2,500. So I've got 0 to, or negative 5 to 20. We'll see if it works. If not, I'll adjust my window accordingly. Did I find the intersection?
Yeah.
Second, trace 5, push enter 3 times, and I get, hold on, what did we say after 10 years? Oh, it's after 10 years it was 3,200. That makes more sense. After 3.5 years it was 23. That's okay though, we made it a little too big. That's not a problem, right? So how long will it take for you to get almost about 4.5 years, 4.49 years is how long it'll take your money to grow from $2,000 to $2,500. Again, sitting in this account, not adding anything to it, just sitting there, you doing no work. Any questions about that so far? If you started with more money, would you gain more?
Yep.
Yeah, percent of a bigger number is more money, right? Okay, suppose you want to have $10,000 in cash in 5 years to buy a car. I want $10,000. Everyone see why I put it there? How much should you put into an account now if we're going to get 5.25% compounded daily? how many years am I putting it in there?
5.
5. So this time what I don't know is P. Now on the last problem I said I would highly suggest using your calculator to solve. I feel differently about this one. Isn't this just multiplied together? Isn't this just some number? I could type this whole thing in my calculator and get a number. What's the fastest way to get P by itself? If this is just a number, divide by that number, whatever that number is. Does everyone agree with that? Now, does that mean your calculator won't work? No, it just means by hand is faster, this on this one. So I'm going to divide both sides by that weird number, whatever it is. So I get 10,000 divided by 1 plus 0.0525 divided by 365. What'd you get?
9,587.8. Oh, no.
Yeah, okay, sorry. 7,691?
Yeah.
Okay.
That'd be right. I did like normal.
10,000 divided by that number. Now, what is this number that I got there? What is that 7,000 number? Which I just answered your question on accident. What is that number that my calculator just gave me? It's the amount of money I would have to put into the account to get 10,000. So $7,691 in 5 years would get me that 10,000 that I needed. Any questions about that one? Y'all ever heard of lottery winners taking less money now to get it now? Have y'all ever heard of that? And people think they're kind of stupid for doing that? Based on this, are they really that stupid? Because what could they do with that money? If they have it all now? They could. What else could they do with it?
Put it in the bank account.
They could invest it. Is there a chance they get more money for the way that the lottery decides how much to give you if you take the lump sum now is they figure out, which it's a little more complicated than this, but they figure out the present value of that money versus the payout. So the payout's more money, but they're going to make interest on it. So it's no skin off their back because they're going to make interest on it and pay you over the next 50 years. Or you're going to get it and make interest on it. One of the two. So that's why the amount is lower if you take it now, because they know you're going to make interest on it if you don't spend it all. Yes, some people just spend it all. You're right. Okay, continuously compounded interest. Again, I want to warn you that this is not very realistic, but the college algebra final may ask it. As soon as you read this statement, your brain needs to completely switch gears to what? A different formula. This is not compounded yearly, it's not compounded monthly, it's compounded continuously. Who? this is compounded continuously. So I'm going to use the continuously compounded formula. Just make sure if you ever read that, you completely switch formulas, it's totally different. It's not that much different money-wise. You could do the calculation like it's not that much more money than daily, but it is a different formula. If it's money, if it's money and it says compounds continuously, use PERT. Okay. Any other one, you're probably using the other formula. You got it. Compound annually, semi-annually, monthly, quarterly, daily, what did I miss any? Weekly. All of those are the other formula. Someone type that in your calculator for me. 4,000 what? So you can see it's not that much more than if you were compounding daily or weekly. A little bit more. Any questions about that one? Oops. Sorry. Yes. You sure? Uh-oh. I didn't do it, so let's check. Yeah, 4,475 and 47 cents. Does that sound better? It is. You'll be okay. But now you know to be careful on your homework. Okay, that look better? Is that what you're all getting? Okay. A child's grandparents, he has some nice grandparents, purchase a $10,000 bond to fund to be used for college education. The bond pays 4% interest compounded monthly. How long would it take for the bond to double? It's always important to ask yourself, which variable am I trying to solve for? And you tell me if it's how long, which variable am I trying to solve for? T, right? Time? I want to know how long, so that's time. I have $10,000 to start with. I am compounded, 4% interest, compounded monthly. Everyone okay with where the 12 came from? I need this variable to be able to solve this, right? I need to only have one variable. What goes over here? Who said the 20,000? Why 20,000? Double 10,000. Again, I would solve this for T in the calculator. I would set my window something from 10,000 to something bigger than 20,000. Are y'all okay if I don't solve this? If I just go on with the... Put it in your calculator, one side in Y1, one side in Y2. Y min at 10,000, Y max maybe 25,000. Does anyone need me to do this in the calculator? Okay? Okay. Let's go to one more example that I do want to do in the calculator. What rate of interest compounded annually is required to double an investment in 5 years? What am I looking for? The rate, right? I am compounded annually. So I have 1 plus r divided by 1 to the 1 times 5. Everyone agree with that? What is glaringly missing in this problem? The principal and the final amount. So what do? I could put 10, what'd you say, 5 and 10? Why did she pick 5 and 10? Right. What if you picked 2 and 4? Or 1 and 2? Or doesn't matter what you pick. That matters. But does the amount matter? no matter what I pick here, if I were to solve this by hand, which I'm not going to, but if I were going to solve it by hand, wouldn't my first step be to divide by the 5? Right? And no matter what this is, if it's double that one, I get a 2. So it doesn't matter what the amounts are, as long as whatever you put in for your principal, you double it. So I wanted to show you that one. Books are notorious for asking this question because it can be done without them giving you the original amount. So I'm going to go to my y equals. You can put in whatever you want for p. I would pick numbers between 0 and 10. That way I don't have to adjust my window real big, right? So I like the 10 and the 5 that Michaela picked. 1 plus r, except r is going to be my x, so I'm going to leave it as x, divided by, how was it annually? Divided by 1. Raised to the 1 times 5. Was it 5? Am I right? Okay, cool. So the x is the r in this case. That's what I'm looking for. Quick question. What do I expect to get as my answer for r? A decimal. In fact, a number between 0 and 1. Probably something like 0.05 or something. So when I go to my window, I have it 0 to 20 and that will work. But 0 to 1 would even work for my x's on this one. It's okay if you left it 20. It wouldn't hurt anything. And then I'm going to do 0 to 20 on my y's. Since I picked 5 and 10, I'm going to get a little bigger than the 10. So it's important to know what you're looking for. Sometimes people make their windows so big looking for rate, they have a hard time finding it. Because it sits right next to the the y-axis and it almost just looks like the y-axis. So you're like, I can't get my window to set. It's important to know what you're looking for. If you're looking for money, it's going to be a big number. If you're looking for an interest rate, it's going to be a decimal. Second trace 5, push enter 3 times, and I get 0.149. What percentage is that? 14.9%. That's really good interest rate. Probably isn't going to happen. But that's asking your money to double in 5 years. So it makes sense. It'd have to be a pretty high interest rate for that to happen. This is your homework. It does get a little discouraging at this time in your life when you're like, oh, interest rates are only 0.5%. On average, the stock market gains about 8% a year. So the stock market's annual return on average is about 8%. So if you do a long-term investment like retirement, you're going to get about 8%. Now again, year to year, very, very volatile, fluctuates a lot, but over a long time it's not that volatile, and you can kind of expect about that much. So if you're diversified, we'll talk about that later. Any questions about this? Do y'all feel like you learned some valuable information today?